Good morning, good afternoon, good evening. I'm very glad to have the opportunity to talk today about one of the most important topics of our times, I believe, the links between climate change and global inequality. This is a satellite image of the US-Mexico border. It shows that even from space, it can be seen that our world is very unequal. What I want to show you today is that climate change, both as its causes and consequences, is intimately linked to global inequality. By global inequality, I mean the inequality between and within countries and societies of living conditions for humans. I mainly talk about income and wealth inequality, but there is more to it, including inequality of opportunity, health, education, etc. While the effects of climate change are global and the projected impacts concern every area in the world, a wide scientific literature shows that climate risks disproportionately affect the poorest countries and people who are more exposed and more vulnerable to their impacts. Here is a map of a vulnerability to climate change index proposed by Frame and colleagues that shows countries' ratio of projected temperature increase compared to observed historical variability, and which can be interpreted as a proxy for sensitivity to climate change. There exists many other such maps of countries' exposition or vulnerability to the various effects of climate change: water stress, intense droughts or heat waves, rising sea levels, loss of agricultural yields, or a degradation of natural habitats. And the emerging pattern is that poor countries are the most exposed and vulnerable. In the poorest economies, a large part of the population depends directly on activities that may be the most affected by climate change, notably the agriculture, forestry, and fisheries sectors. People with the lowest income are the most likely to depend for the survival and resources provided by nature. Rising temperatures are exacerbating pre-existing disparities in access to clean water and affordable food. Most of the time, the poorest population do not benefit from insurance mechanisms or do not have access to basic health services, making them particularly vulnerable to any shock hitting their assets and income streams. Climate change amplifies risks for the poorest and exacerbates pre-existing inequalities. A greater effect of climate change on the poorest can already be measured at all scales. Climate change has tended to increase inequalities between countries, and one study by Diffenborg and Berkey suggests that the ratio between the last and first deciles would be 25% lower in the absence of climate change. While inequality refers to differences in income or wealth across the whole distribution, poverty concerns individuals below a given income threshold or lacking access to basic needs. By hitting the poorest hardest, climate change risks both increasing existing economic inequalities and causing people to fall into poverty. Without action to limit and adapt to climate change, its impacts will continue to amplify inequalities both between and within countries, and could undermine development and poverty eradication. A World Bank report estimates that an additional 100 million people could be pushed into poverty by 2030 as a result of climate change. So mitigating climate change is one of the conditions for sustainable improvement of living standards around the world. And it is the populations of these economies most vulnerable to climate change who contribute the least to the accumulation of greenhouse gases, the cause of climate change. Greenhouse gas emissions today are mainly linked to the level of a nation's wealth. The richest countries represent only 16% of the world population, but almost 40% of CO2 emissions. On a per capita basis, average emissions are almost 20 tons of CO2 equivalent a person a year in the United States. That is approximately double the average amount per person in the European Union or in China, and almost 10 times the amount in India. Even a lot more than that for Madagascar or Somalia, for instance. This cross-country inequality is rooted in history. The contribution of the developed economies to global warming is greater than the share of current emissions because they have added to the accumulation of greenhouse gases in our atmosphere for a longer period. Here is a map of the country's share of global cumulative CO2 emissions since the Industrial Revolution. For example, the contribution of the United States to cumulative emissions is about 25% of the total. The European Union's 22%, China's 30%, India's 3%, and also 3% of the whole African continent. If emissions from the production of goods are relocated to the countries where the goods are consumed, the gap between richer and poorer countries widens further relative to the gap in territorial emissions. Indeed, developed countries are globally net importers of emissions embedded in trade, and emerging and developing countries are net exporters. As you can see in this graph from the latest Global Carbon Project publication, OECD consumption-based emissions are larger than its territorial emissions. Within countries, household emissions are also vastly unequal. Incomes are the first determining factor of household emission. It has been robustly shown for European countries, China, USA, etc. But there are also large variations within income classes depending on location, urban, suburban, rural, age, lifestyle, etc. Overall, on a global scale, the top 10% emitters are responsible for about 48% of total emissions, while the bottom 50% represent only 12% of emissions. However, for many countries and between countries, emissions inequality is often lower than incomes inequality. And this is important because it means that mechanisms pricing emission would often represent a higher share of poorer households or countries' wealth. So global inequality could be reduced by mitigation action because inequality exacerbating climate change impacts are avoided. But the costs of reducing greenhouse gases may also, depending on how climate policy are designed and implemented globally, they can be evenly distributed and potentially induce inequality. Depending on which effect dominates, climate change mitigation policies could reduce or increase inequality. And we are in a context where, since the 1990s, inequality between countries have been reduced, unlike the inequality within countries, driving global inequality down. Here you see the evolution in global inequality since 1960, measured by the Genie Index. The higher the index, the higher the inequality. A Gini of 0 would mean perfect equality of incomes of all individuals, and a Gini of 1 would mean one person would concentrate all the world's income. And you can see two things. Global inequality is still mainly driven by inequality between countries, and it is falling thanks to between countries inequality reduction over the last 3 decades. But this declining trend could be reversed in the coming decades due to climate change. That's what we explored in an article published last year in the journal Climatic Change with my colleagues Nicolas Taconet and Aurélie Méjean. We wanted to know how climate change might interact with socioeconomic development in demography, education, and technological progress, and influence how inequality between countries would evolve in the 21st century. To answer that question, we considered the available projections and associated uncertainty along 3 dimensions: socioeconomic development, economic impacts of climate change and their distribution across countries, and economic costs of mitigation action. That is, macroeconomic implications of investments in low carbon solutions and structural change away from emitting activities along mitigation pathways in their distribution across countries. We combined them in a common framework. We started from the 5 main socioeconomic scenarios currently used in climate change research, the shared socioeconomic pathways, SSPs, which make contrasting assumptions about demographic development, education policies, governance, and growth in different regions of the world. We are also taking from the shared socioeconomic pathways existing estimates of the cost of reducing greenhouse gas emissions to levels compatible with the representative concentration pathways 2.6, 3.4, 4.5, and 6.0, which are spanning a range from continued global emissions increase until mid-century, followed by a modest reduction for RCP 6.0, to reaching net zero CO2 emissions around 2070 for RCP 2.6. Because the mitigation costs in the SSP database are only available at the regional aggregation, we're making further assumptions on the distribution within regions, either equally or proportionally to countries' wealth. We have combined these with existing estimates of temperature change caused by emission pathways from CEMIP 5. And with existing estimates of the economic impacts of climate change coming from several studies. To give you an idea, the implied economic losses due to a 2-degree warming range below 2% to about 20% at the global aggregated level in the alternative damage functions we're using. So combining all these alternative estimates gives us over 3,000 scenarios with projections of GDP and GDP per capita at the country level up to the end of the century, accounting for uncertainty in socioeconomic assumptions, emission pathways, mitigation costs, temperature response, and climate change. We further compute the Gini coefficient of future inequality between countries in the 21st century and the different levels of climate change. The main results are summarized in this graph, which shows the evolution between 2020 and the end of the century of the Gini coefficient of inequality between countries, international inequality weighted by population, for different assumptions for socioeconomic evolutions, the 5 SSPs, and according to different estimates of the damage caused by climate change. In red, the highest estimates, and in blue, the lowest. The Genie Index measures the difference between the actual distribution of income and an equalitarian situation where all countries would have the same GDP per capita. The higher the Genie Index, the higher the inequality. For each damage estimate, the solid line represents the average value for all scenarios, and the dotted lines represent the range of uncertainty. The range is larger in the case of high damage estimates, because in that case, the uncertainty on emission levels and on temperature response to emissions matter more. Under the highest damage estimates, inequality increases again as the impacts of climate change unfold, regardless of the assumption of socioeconomic change. This graph shows that climate change may become a major factor determining the evolution of inequality in the world, as important as demographic factors, technical progress, education, and governance. If the highest projections of future economic damage in the current scientific literature are realized, climate change would reverse the gains of recent decades and leads to a further increase in inequality between countries in this century. But what is also important to look at is how mitigation, the reduction of greenhouse gas emission to limit the extent of climate change, affects inequality. Because ultimately, this increase in inequality is not inevitable. This is not visible on the graph here, but we analyze it in the article. What we find is that the lowest emission trajectories, and in particular the emission scenario compatible with the 2-degree target of the Paris Agreement, are those that have lower levels of inequality and allow to delay or avoid the date at which inequality between countries starts to rise again. These low emission trajectories are also those where the situation of the poorest countries is the best. This is a robust result across a wide range of uncertainties. It holds except in scenarios combining low level of climate damage and regressively distributed mitigation cost. This suggests that climate change mitigation is essential to limit future inequality, provided that the cost of reducing emission do not fall too heavily on the poorest countries. Obviously, our study has many limitations and is not the end of the story. In particular, it doesn't look at within countries inequality, which, as we saw in the beginning, is a rising concern in many countries. But other studies have looked at how mitigation policies affect within country inequality, but often in frameworks that do not include impacts from climate change. There are even systematic reviews of such studies, and here are two recent ones. They establish that contextual factors in policy design and implementation determine whether climate policies reduce or increase economic inequality and poverty. The important point they show is that potential negative inequality impacts of climate policies can be alleviated and possibly even reversed, but it requires attending to distributive and procedural justice in all stages of policymaking, and focusing on the carbon intensity of lifestyles, well-being and decent living standards for all, and targeting the emissions of the richest and highest emitting households. So to wrap up and conclude, a few take-home messages. The countries and individuals most vulnerable to climate change impacts have the least contributed to the accumulation of greenhouse gases causing the problem. Without action to limit and adapt to climate change, its impact would continue to amplify inequality. Through avoiding those impacts of climate change, which fall more heavily on low-income countries and communities and households, mitigation reduces inequality and poverty. But climate action must not neglect its own impact on inequality. And there's still a lot to understand to connect mitigation pathways and global inequality reduction. Why is this important? These links between climate change and global inequality make the responses to climate change a fundamental equity and justice issue. Also, it has been shown that because the benefits of mitigation accrue more to poorer countries and individuals, it gives more social value to mitigation. So I hope this short talk has given you the inspiration to dig deeper into the topic. Here is a recommendation of a place to start. It's a shameless auto-promotion because that is where one of the pieces of work by Laurent Taconet and myself I used in my first slides is published. But there are many more fascinating contributions in this collective volume that sheds light on the effect of economic and power inequality on environmental dynamics, and conversely on the economic and social impacts of environmental dynamics. And I invite you, why not, to join the community of scholars who research the many dimensions of the interlinkages between inequality and climate change.